we handle general exponential functions that does not have e as its base? So what happens if the exponent is g of x? So if y is equal to b to the power of g of x, then the derivative is given as y prime is equal to b to the power of g to the x times ln of whatever the base is times the derivative of that exponent. So for example, again, if f of x is equal to e to the g to the x, then f prime of x, if it's not e, that should be wrong. This is e. Is going to be e to the power of g to the x times ln of e. But because ln of e is always 1, we don't need that there. Okay, because we assume it is 1. Remember, ln of e is equal to 1. And then we multiply by the derivative of the exponent. However, if b is not e, then we take, but to take the derivative, we take the original function, which is b to the power of g to the x, multiply by the ln of that base, and then we multiply the derivative by the exponent. So the first one we have is y is equal to 5 to the x. Remember, 5 is not e, so this is not e. So if we follow those rules, you get y prime is equal to 5 to the x times the ln of that base times my derivative of x in the exponent, which is just 1, which gives me 5x times ln 5, which gives me ln 5 times 5 to the x, which is fine. So that would be your answer. So there should be a ln 5 right here. Let me just write that more neatly. All right. And now my next one we have is y is equal to pi to the power of x. Now, following those rules, what do you think my derivative of y is equal to pi to the power of x gives us? Yep. Because my base is not e, I have to write ln of e in the middle. So my derivative is just pi to the power of x times ln of pi, which is my base, times the derivative of my exponent x, which is just 1. So I'm left with pi to the power of x times ln of pi. That would be my derivative. Thank you, Priyanshu. Perfect. And then my last one is we have my derivative is equal to 1 over 2 to the x times ln of 1 over 2 times my exponent, which is 1. So what this simplifies to using our laws of log is 1 over 2x times negative 1 of 2, which just gives me like negative 1 over 2 times ln of 2. This is from, I believe, the second lesson, which is my laws of logs. Guess we got a couple more examples, and then we will be on our way to having a nice, relaxing evening. So now I want to figure out my derivative of y is equal to root 3 to the power of x squared. So again, y prime is equal to my original function times the ln of my base, which is ln of 3 to the power of 1/2, times the derivative of my exponent, which is 2x. So again, we have the power rule with ln of 3 to the 1/2. So this gives me root 3 times x squared times 1 over 2 ln 3 times 2x. So as you can see, this cancels each other out. So we're left with root 3 to the power of x squared times x ln 3. So that would be the derivative for this function. And then last but not least, sometimes you can't simplify it all the way. You're sometimes going to get a very long answer, which is going to be the case with the next one. So I get y prime is equal to my original function times ln of 3 multiplied by the derivative of my exponent, which is going to be 2x plus 2. Okay. Now, if I rearrange it, I can get 2x plus 2 times 3 to the x squared plus 2x times ln of 3. I can factor out a 2 from my first bracket, so I get 2 times x plus 1 times 3 to the power of x squared plus 2x times ln of 3. And I cannot simplify anymore, so I would leave my answer as that. And then we have my last example, which is to find the equation of the tangent line to the curve. Y is equal to negative 3 times e to the x, where x is equal to ln of 2. So let's just take my derivative. So I need to take my derivative of negative 3 e to the x. So what that would look like is negative 3 times e to the x times 1 times the ln of e. So I get my derivative as e as negative 3 times e to the x. So all I did was keep my negative 3 outside the bracket and just did my derivative for e to the x, which is just e to the x, which is why my derivative is able to be written as y prime is equal to negative 3 times e to the x. Now I need to figure out my slope of the tangent, where x is equal to ln of 2. So I need to sub in ln of 2 for x. So negative 3 times e to the power of ln of 2. So if we look back to my laws of natural logarithms, when I have it in the form of e to the power of ln of 2, my solution to that will always be what my exponent is. So in this case, e to the ln of 2 just gives me back 2. Okay, because of my rule, e to the ln of x gives me back just x, which means I will just be given back a value of 2, which means this is equal to negative 3 times 2, which gives me negative 6. So this is the slope of tangent. Now, I need to evaluate y at that same point to figure out my y coordinate. So y such that x is equal to ln 2 is equal to negative 3 times e to the ln of 2. And again, we have that same rule. So we get negative 3 times 2, which gives me negative 6, which means my point is going to be ln of 2 and negative 6. So now what I can do is make my equation. So I get y minus y1 is equal to m times x minus x1. So I get y minus negative 6, which is y plus 6, is equal to negative 6 times x minus ln of 2. So I get y plus 6 is equal to negative 6x plus 6 ln 2. Then I'm going to move everything over. So I get 6x plus y plus 6 minus 6 ln 2 is equal to 0. And this will be my constant value.